In Philadelphia, Benjamin Franklin faced a problem familiar to every modern traveler. His vape was dead, and the nearest electrical socket had not yet been invented. Fortunately, Philadelphia had weather. Franklin was a printer, diplomat, inventor, and founding father. More importantly, he was a man constitutionally unable to leave a perfectly serviceable object unmodified. The crisis began one damp afternoon when Franklin's portable vapor apparatus expired halfway through a pamphlet. This was a serious interruption. 18th century pamphlets were extremely long, and Franklin had already used all the interesting words. The device had several advantages over a clay pipe. It produced no ash, required no tinder, and did not fill his bifocals with smoke. Its one weakness was electricity, then available chiefly from clouds and badly carpeted rooms. Electricity itself was not new. European natural philosophers had generated static for years, mostly by rubbing expensive objects and looking pleased. Franklin did not discover it. What he did was organize the subject with the confidence of a printer correcting someone else's spelling. He popularized terms including positive charge, negative charge, conductor, and battery. These remain useful today, particularly when blaming the wrong end of a cable. The most promising device in his laboratory was the Leyden jar, which could store an electrical charge. It was the 18th century power bank, except it was made of glass and capable of correcting posture. Franklin attached the jar to the vapor apparatus with the confidence of a man for whom instructions had not yet been standardized. There was a blue flash, a sharp report, and the smell of singed wool. The device remained flat. Franklin became briefly less so. This was not his first electrical mishap. During an earlier demonstration, Franklin had tried to kill a turkey with electricity and shocked himself instead. He later described the incident as mortifying. The turkey, whose correspondence has not survived, appears to have regarded it as encouraging. Franklin therefore concluded that the problem was not the vape. It was Philadelphia's charging infrastructure, which consisted chiefly of a shed. A laboratory spark and a bolt of lightning shared the same color, the same crack, and the same general rudeness. Franklin suspected that they were the same phenomenon, operating at radically different customer service levels. His first proposal involved placing a pointed metal rod on a tall church. Philadelphia had several churches. The clergy were unexpectedly reluctant to become adapters. So Franklin selected the next tallest object available to a man standing in a field, a kite. The design was elegant. A silk handkerchief formed the sail. A sharp wire rose above it to gather electrical charge. Hemp cord carried the charge downward when wet. A dry silk ribbon insulated the operator. A metal key joined the two lines because the universal connector was still awaiting committee approval. The key could also feed a Leyden jar, and the Leyden jar could feed the vape. The entire system was, in modern terms, a charging cable with weather at one end. Franklin's assistant was his son William. Later paintings often showed William as a small boy, presumably to make the experiment appear more educational. In reality, he was fully grown and therefore old enough to understand that saying no was an option. They raised the kite as dark clouds moved over Philadelphia, then sheltered inside the doorway of a shed. This combined sophisticated experimental physics with the safety policy of standing slightly indoors. Rain soaked the hemp line. Wet fibers conducted charge from the sharp wire towards the key. The silk ribbon remained dry, separating Franklin from the sky by several inches of optimism. Nothing happened. Then the loose strands of hemp began to lift. They stood away from the cord as if repelled by an invisible force. The sky had found the cable. Franklin moved his knuckle towards the key. A spark jumped across the gap. Today, this would invalidate the warranty. In Philadelphia, it counted as peer review. He brought the Leyden jar to the key and collected what he called electric fire. Charge traveled from the cloud to the wire, along the wet hemp, through the key, and into the jar. Crucially, the kite itself was not struck by lightning. A direct strike would have shortened the experiment and most of Franklin. Only after the jar held a measurable charge did Franklin connect the vapor apparatus, having learned that science is the art of shocking the cheaper object first. For one improbable moment, nothing happened. Then the ceramic coil developed a faint amber glow. The device gave a dignified hiss. Franklin inhaled. Philadelphia exhaled. The cloud was visible from 3 streets away. A neighbor reported thunder at ground level. Another claimed the odor resembled mint, molasses, and constitutional compromise. By morning, the city knew that Franklin had bottled electricity from the sky. The Pennsylvania Gazette described the electric fire in sober detail and, in the interests of editorial dignity, omitted the flavor. The experiment supported Franklin's argument that lightning was electrical. It also strengthened the case for the lightning rod, which guided a dangerous charge safely into the earth. This was surge protection for an entire building rather than one gentleman's desk. So did Benjamin Franklin discover electricity while charging a vape? No, electricity was already known. Franklin demonstrated that lightning was electrical while charging one, a distinction both pedantic and, in Philadelphia, life-saving. His experiment transformed the storm from an act of heaven into a measurable natural phenomenon. It changed science, architecture, and the acceptable distance between a statesman and a cumulonimbus cloud. The vape was fully charged. Franklin, for several seconds, was as well.